In a previous video, I talked about the merge sort concept. The principle is actually pretty easy to understand. Take a list and split it into two, repeatedly, until you have several lists each of only one item. Then merge pairs of lists back together, sorting as you go. I also showed you that the same outcome can be achieved by focusing on one side of the list at a time. Split a list whenever you can and merge pairs of lists as soon as you can. As you'll see now, it's important to appreciate this approach. To take things a stage further, in a previous video I talked about an algorithm that will split a list into two. In another video, an algorithm that will merge two ordered lists together. Now I'm going to show you how these algorithms might be combined to create a working merge sort function. Later I'll show you a VB.NET implementation of my algorithm, which will fill in some of the details. So here's some pseudocode for a merge sort function. The function has the name merge sort. Well, why not? It takes one parameter, an array, or if you like a list, that needs to be sorted. The first thing that merge sort does is to test the size of the array that's passed to it. If the array has only one element, merge sort simply returns the same array and exits immediately. The merge sort function calls two different helper programs, a procedure with the name split list and a function with the name merge two lists. The merge sort function also calls itself. This is very much a recursive approach. Let's see how it works. This is the array that merge sort is going to process. And here's a representation of the call stack. The merge sort function has now been invoked and it's running. This first invocation of merge sort has a stack frame on the call stack. The array is larger than one element, so the code within the if block is skipped and merge sort calls the procedure split list, passing it the array as a parameter. First time around, split list is passed the entire unsorted array. Split list is also passed two empty arrays to populate, R left half and R right half. Both of these will have been declared without sizes at the top of the merge sort function. That particular detail isn't shown here. Once it has control, split list will dimension the empty arrays according to the size of the array it has to split, and it will then populate them. The empty arrays are passed by reference to split list, so they can be accessed by merge sort once split list has done its job. Split list populates the two empty lists and control comes back to the merge sort function. Now merge sort calls itself, passing in just the left hand side of the list. A second invocation of merge sort begins. The first invocation is at the bottom of the call stack and is now suspended. The new invocation of merge sort is working with only half of the original list, the left hand side. As far as the second invocation is concerned, the list has only 4 items to sort. Split list is called again, this time by the second invocation of merge sort. And a smaller array is passed to it this time, along with a couple of empty arrays for it to populate. Again, split list does its job, then control is returned to the caller, that is, the second invocation of the merge sort function. Now, the second invocation of merge sort invokes itself, passing in just the left-hand side of the list that it was working with. So a third invocation is activated, and it is now working with an even smaller array. The second invocation is now also suspended on the stack. The split list procedure is called again. This time it's passed an array of only 2 items, along with a couple of empty arrays. The empty arrays are populated, and the third invocation of merge sort is now back in control, only to call itself again, passing on the left-hand side of its list. Which means we now have a fourth invocation of the merge sort function, active at the top of the call stack. But this invocation is working with a list with only 1 item in it, so it can't be split any further. It returns what it was passed and exits immediately. So now the third invocation resumes from where it left off. It calls itself to split the right-hand side of the list that it was working with, and a brand new fourth invocation begins. But this too finds that it's working with a list with only one item, so it returns what it was passed and exits without further ado. The third invocation resumes from where it left off and now calls the function merge two lists. Merge two lists is past the pair of arrays that the third invocation was dealing with, and it merges them into one sorted list. Once the lists have been merged, the third invocation of merge sort regains control and then comes to a natural end. The third invocation is removed from the top of the call stack, leaving the second back in control and able to pick up from where it left off. The second invocation of merge sort calls itself to split the right-hand side of the list that it was working with. And a new third invocation takes over. Split list is called, which does its thing, and when it ends, the invocation of merge sort at the top of the call stack, that is the third one, calls itself. A brand new fourth invocation of merge sort is activated. But this one doesn't last long. It's working with an array of only one element, so it returns it and exits. The third invocation resumes and attempts to split the right-hand side of the list it was working with, and a new fourth invocation begins. But it too has nothing to do but to give back what it was given and exit. The third invocation of merge sort continues. It calls merge two lists, and its two single item lists are brought together in the correct order. The third invocation of merge sort regains control and comes to a natural end. Its work is done. The third invocation is removed from the top of the call stack, leaving the second back in control and able to pick up from where it left off. The second invocation of merge sort was dealing with two lists, each of two items, and it's now ready to merge these into one sorted list. Merge two lists is called, and the two halves are brought together in the correct order. Now the second invocation of merge sort can come to a natural end, leaving the very first back in control and ready to go to work on the right-hand side of the list that it was working with. The original invocation of merge sort invokes itself, passing in the right-hand side of the original list. A brand new second invocation begins. It calls split list. Split list obliges, then ends, and a second invocation of merge sort goes to work on the left-hand side of the list by calling itself. A new third invocation takes control and splits the list that it was given. The active invocation of merge sort invokes itself by passing a list of only one item. A new fourth invocation begins, but it has little to do. The list is already fully split. So the third invocation takes back control and calls itself again, passing in the right-hand side of its list. Another fourth invocation begins, but this too has nothing to do but to hand back control to its caller, which is now all set to merge a pair of lists. The lists are merged in the correct order, and another invocation of the merge sort function can come to a natural end, leaving its caller back in control with some work still to do. The right-hand side of the second invocation's list needs to be dealt with. A new third invocation is brought to life. The list is split in two. An attempt is made to split the left-hand side even further, but another invocation has little to do but to hand control back to its caller. Now an attempt is made to split the right-hand side even further with another self-call. But as before, the list can't be split any further, so the third invocation has only one last job to do. Call the function to merge its two lists together. The third invocation of merge sort now ends gracefully and relinquishes control to its caller. And it, too, has only one last job. Two ordered lists are merged, and yet another invocation of merge sort comes to an end, leaving the very first invocation back in control, and it too has only one last thing to do to finish the job. Merge two lists is called for the final time. and the original process can finish, and the call stack can be cleared.